All right, so we are going to take notes in our textbook, so go ahead and get that out. Flip to page M2-121. I will try to make these notes as quick as I can, but there is a lot to go over. So we're going to start just by kind of reviewing something that should have been taught in 8th grade. I know some of you guys learned it very well in 8th grade. Some of you guys didn't learn it very well in 8th grade, but that's the concept of inequalities. Okay, and so kind of what I'm going to illustrate here is if I have this bubbly water, this can of bubbly water, okay, it has a fluid ounces of about 12 ounces, so it says 12 fluid ounces, right? We don't know how much water is in here, okay? It could be completely full, and there could be a full 12 ounces, or there could be 0 ounces, right? So if we kind of wrote that as an inequality, we know that there is less than or equal to 12 ounces. Now, technically, we also know that there's, and there's more than or equal to 0, right? So we kind of know it's some number in between 0 and 12. Now, if I flipped it over, now we know, okay, for this one, x is just 0, right? It's just 0, that's what it is. But if I had another can of water, right, and this one does have some in it, you can kind of hopefully hear, right? There is some water in here. I'm not going to tip it over. But there's an amount of water in this. We just don't know how much. It might be full. It might be a little less than full, right? But it's some number in between 0 and 12. But we don't actually know. We can't see inside of it. So we just know it's some number that's basically less than 12 and also that's greater than 0. But without actually measuring it or pouring it into something, that's pretty much as far as we can get. And so inequalities kind of help us with that uncertainty. Right? Inequality meaning not equals. So the main 4 signs that we use here are greater than, less than, greater than or equal to, and less than or equal to. But not equals to is actually a sign as well. So make sure that we're comfortable with these. I don't really want you trying to use tricks and, it's pointing this way, it's pointing that way. You just kind of have to memorize them. I mean, it's really not that hard as we get into high school to just kind of memorize a few extra symbols, right? We all know what a square root symbol is. We need to memorize these symbols. One thing I do want us to watch out for, in between, say 6 and 3, it's very obvious what symbol would go here. 6 is greater than 3. But when I flip it negative, some students get confused. -6 and -3, what symbol would go in between these would be a less than symbol. Because -6 is smaller than -3, it's more negative, right? And to illustrate that, if you kind of drew a number line, it would help yourself out. So anything to the right side is bigger, right? That's obvious. And anything to the left side is smaller. So if this is review for you, that's great. But just kind of going over it really quickly, obviously 3 is smaller than 6, right? But then -3 is to the right of -6, so -3 is bigger than -6. So when we're solving for these, we solve for them the same way as if we would have solved for an equal sign. So x plus 1 equals 6. We would subtract 1 to both sides. We get x equals 5. I think all of us are very comfortable with that. Now if I have x minus 2 is greater than 5, we just pretend it was an equal sign, right? Add 2 to both sides. And then we just write x is greater than 7. So x is greater than 7 instead of x equals 7. Right, if we had something like this, same process, right? X divided by 3, we want to get rid of our fraction. So multiply 3 to every term. And we get x is less than or equal to -3. Then this last one has a little bit of a special trick. Okay, it's a little bit of a special trick to it. And that's because anytime we divide or multiply by a negative number, something special happens to this inequality. So whenever I divide by a negative number or multiply by a negative number, that inequality actually flips between negative and positive. 4 divided by -1 is -4. So this answer is x is less than -4. That inequality sign flipped. Okay, to show you why that is, if we imagine another statement, like let's say we imagine 10 is less than x. Yeah, this is kind of written backwards. This is written backwards, but since 10 is smaller than x, what would be a number that would work here? 12 would work, 13 would work, 100 would work, right? So basically, if I read it backwards, we're going to kind of think if 10 is smaller than x, then backwards, x has to be greater than 10. And you can always do this. So you can always like flip sides. When you flip sides, you flip signs. That's kind of what I remember is when you flip sides, you flip signs. Right? And so it's kind of like reading it backwards, right? Like I like to think if I'm reading this backwards, x is, if I read it backwards, the less than would become a greater than 10, right? X is greater than 10 reading it backwards. So that's actually kind of what happens when we have negative x is greater than 4. Okay? Because what I could do is I could add x to both sides to make the x positive. Okay? And then since I want to get x on one side and my number on the other side, I'm going to subtract 4 to both sides. And so I get negative 4 is greater than x. Well, now I want to flip sides and flip signs. So I'm going to get x, flip my sign, is less than negative 4. And if we notice from here to there, we flip the sign. Now, instead of doing this is kind of like really long. We're just going to remember that whenever you divide or multiply by a negative, you flip signs. Okay? So we can write that like as a rule if you don't know that rule from 8th grade. If you know that rule, that's great, but I'm going to just write it in. When you divide or multiply by a negative number, so it works for multiplying 2, flip the inequality sign. Now, why did we not flip it in number 3? Why did we not flip it in number 3? There is a negative in number 3, but it's not what we multiplied by. What we multiplied by was times 3 and times 3. So we didn't flip it. Had we multiplied by negative 3, we would have flipped it. Okay, so that's the key difference. All right, so jumping into our main topic here, we're going to use Alan's camping troop. They're selling popcorn for a fundraiser. It says each camper starts, that's a keyword, with a credit of $25. When you start with something, that's usually our y-intercept, our b. And then each box of popcorn sells for $3.75. When we're selling like each of something, generally that's a keyword for our slope. Right? So if we were to write this into y equals mx plus b, right, we would have y equals 3.75x plus 25. Now they said let's write it with the function f of b. So instead of y, I'm going to use f of b. And instead of x, I'm going to use b. So there is our function form using f of b. Right? So analyzing this, identifying the independent and dependent quantities. The independent would be, the b, the number of boxes that they sell. The dependent, that would be our money. Right? So that would be f of b, and it would be like the dollars that they earn. Okay. What is the slope? The 3.75. That's how much each box costs. The y-intercept's the $25. That was their starting credit. Okay. So we won't really fill those in. I want to jump ahead and go quickly. So now we have this graph. All right, and suppose Alan has a sales goal of $1,600. So he's trying to reach a goal of $1,600. So, if we were thinking about when would that happen, we could draw a horizontal line at 1,600. All right, so at 1,600, we could draw a line here. When we draw a line, I like to, add our arrows. So at 1,600, where does it intersect with this graph? It intersects with that graph at a point. We kind of drop this down. It's in between the 360 and the 480. And if we want to figure out what we're counting by here, I have 2 tick marks until I hit 120. So if I do 120 divided by 2, we get 60. So we're counting by 60. So that's 60, 120, 180, so on. 360 plus 60 is 420. Okay. So that's where it crossed out. So it says draw horizontal line. We did that. How many boxes would Alan have to sell to make $1,600? He would have to sell 420 boxes. Explain your reasoning, because that's where the graph intersects. So it intersects with y equals 1,600 at 420. Okay. So using the number line, represent the number of boxes sold if the total sales is equal to 1,600. So it's 420, so we're just going to put a point at 420. I'm going to put above. I like to put mine above. So we're just going to put a point there at 420. Okay. And that's how we do that. So that represents basically, x is equal to 420 boxes. All right, now analyzing the graph. It says analyze the region of the graph, like region being like the section of the graph that lies below the horizontal line you drew up to and including, that's important, the point intersected by the line. So up to below the horizontal line, so below the line, the section below the line of the graph, that's kind of this, and including it, right? So if I were to highlight that, if you had a highlighter, I could highlight that. I would highlight the point as well. If we were to circle it, we could circle this. I would circle, everything below, including the point. So that's the area we're looking at. So we want to look at that area. So what does this region of the graph represent? Well, this represents basically how many boxes Alan sells before he passes his goal, right? Before he passes his goal. He can reach his goal, but he can't pass his goal. Right? Or how many boxes he sells, if he's made $1,600 or less, right? So this is when he's made basically like, $1,600 or less. So writing an inequality, well, what was our money? Our money was f of b, and it's 1,600 or less. That represents less than or equal to 1,600. Right? The less than because it's below, the equals to because it included that point. Then it asks us to use this number line to represent the number of boxes that are solutions to that inequality. The solutions would be the x values, what values would work for that. So remember, x equals 420 would work, and any x smaller than 420 would work, right? All of these x's would work. So that would represent kind of x is less than or equal to 420. That would be our inequality for the solutions. So just like we wrote our point in here earlier, we would write that again. But this time we're also going to include an arrow pointing to the left. Okay, this arrow is going to point to the left. You don't have to draw it all the way over, right? That means it's just going to keep going forever off to negative infinity. So any number smaller than 420 would work. 240 would work, 180 would work, 60 would work, but even negative numbers would work. Okay, and so does that make sense for this problem to have negative numbers that work? No, the negatives wouldn't really make sense. You can't sell negative boxes of popcorn. So the negative numbers don't really make sense in our context, but sometimes that happens in math. We just kind of have to analyze it. So next we're asked to analyze the region of the graph that lies above the horizontal that we drew. And this time it says not including, okay, not including the point. So not including that intersection, but up above. So I'm not going to circle the point, and I'm just going to circle what's above the region. So now we're kind of looking at that. This is when he's made more than $1,600. And that would be after he sells more than 420 boxes. So what does this represent? We just kind of talked about it. I'm not going to write it in. Write in inequality. So f of b would be more than $1,600. And we said that happens when x is more than 420. So he sells more than 420 boxes. He's going to make more than $1,600. Kind of obvious. Now, when we put in our point this time, though, it's not including 420. So instead of doing a closed circle, we're going to still put a circle here, but we're going to leave it open. And we're going to draw our arrow to the right. The reason we're drawing our arrow to the right is because it's greater than 420. It's bigger numbers. So we're going to open that circle because it doesn't reach 420. He can't sell 420 because we want more than $1,600. Okay? Now, do all of these numbers like 480, 481, 482, 43, even 1,000, do all of those numbers make sense? Yes, they would make sense for the most part. I'm going to say yes because any positive number is possible. Technically, though, this goes out to 1 million. So technically, at some point it's going to stop making sense. So I'm going to kind of put like sort of, up to a point, right? It's not going to really make sense for a camping troupe to sell 2 billion boxes of popcorn, or even 30 billion boxes of popcorn. There aren't 30 billion people on the planet. So, the arrow at some point, it's going to stop really making sense for the problem. But, technically, yeah, it makes sense. If they sell more than 420, any number, they're going to make more than $1,600, right? So if you're not good at those, graphing those, this question says explain the differences between open and closed circles. But I also want to even explain the differences between the left and the right. So anytime I have, like, say, x is less than a number, like x is less than 3, we graph that by, here's 0, 1, 2, 3. We put a 3 in, and we point to the left, right? Less than, it has an L. We're pointing to the left. If we had x was greater than 3, same thing, like 0, 1, 2, 3. We put a circle, and we point to the right. Greater than has an R. We point to the right. Okay. And then if we have x is less than or equal to 3, we put in a closed circle, and we point to the left. And x is greater than or equal to 3, we put in a closed circle, and we point to the right. Okay, so with an open circle, we use open circles for less than or greater than, and those don't include the point. Whereas we would use closed circles for less than or equal to or greater than or equal to, and they do include the point. So that's our main difference. Okay. So using the graph, it says use the graph to answer each question. I'm going to kind of use the graph and the equation, and I'll explain why. How many boxes would Alan have to sell to earn at least $925? Okay, so $925. So if we go up to $925, the problem with just using the graph is I don't really know exactly where 925 is. That's about 900. 925 would be a little bit over it. It looks like it's right there. Like, it looks like it's dead on at 240, but I'm not 100% sure. So I think it's probably at 240, but I'm going to use our equation just to be safe. So this was our equation, f of b equals 3.75b plus 25. And let's use that just to be safe. I'm thinking it's 240, but let's make sure. Okay. So the other thing, though, is it says at least. It says at least. I want to talk about that wording and a couple other wordings. So when we say at least always means greater than or equal to. This is the one that people get the most confused on. A lot of times people see the word least and they want it to mean less than. But in English, when I say, if I said I have at least 3 cookies in my cupboard, that means the smallest amount is 3. At least 3 means 3 or more. Okay, so at least really means, that number or more, which is greater than or equal to. The opposite of at least is at most. If I said I have at most 10 cookies in my cupboard, that means the maximum, the biggest amount is 10, but I also could have less than that. So at most means less than or equal to. And then fewer than would mean less than. That's kind of more obvious. More than would be greater than. That's also kind of obvious. So just kind of making sure we're good with that vocab. So when I say at least 925, what that means is that means that f of b is, we said at least means greater than or equal to. So we're going to use greater than or equal to here. So f of b is greater than or equal to 925. Now, I thought that, that would mean that that's happening at, I think that that's going to happen when x is greater than or equal to 240. That was like my guess from the graph, but let's prove it. So what I'm going to do is where I see f of b, I'm going to put in 3.25b plus 25. Okay, how would I solve this? I would subtract 25 to both sides. You would get 3.25 is greater than or equal to 900. B, 3.25b. I'm isolating for b, so I'm going to divide both sides by 3.25. And on your calculator, you can do this on a calculator. When you divide 900 divided by 3.25, you do get 240. Okay. So that did match up with the graph, right? It matched up with the graph pretty perfectly. And so it's 240 boxes or more, then he's going to make at least $925. How many boxes would Alan have to sell to earn less than $2,050? So how many would he have to earn less than $2,050? Less than is kind of an obvious one, right? So we would say f of b is less than $2,050. Let's do this the same way. So we won't even look at the graph first, and then we'll verify it on the graph. 3.25b plus 25 less than 2,050. Okay. Let's subtract 25 to both sides. We get 3.25b is less than 2,025. Okay. Then we'll divide both sides by 3.25. And again, you can take out a calculator for this. And we end up with, when you type that into your calculator, 3,025 divided by 25, we get B is less than 540. Okay, so 540, he could not sell 540 boxes, but he could sell 539, 538, or any number less than that. So kind of looking back at the graph, right, 2050, well, this is 2000, 2050 would be like up here a little bit. And yeah, it kind of makes sense, 540 would be here. It looks like it'll probably pass through there. So we couldn't have even totally done it on the graph, but it looks like that makes sense, and you know, we did our work, so that is the right answer. Okay. And then one more of these. We have, how many boxes would Alan have to sell to earn exactly $700? Exactly just means equal. So we're going to say f of b is equal to 700, exactly. Right? 3.25b plus 25 equals 700. Subtract the 25 from both sides. 3.25b equals 675. Divide both sides by the 3.25b. And when you do that on your calculator, you end up with 180. You get b equals 180. Now it's equal sign this time. Let's check it on the graph. Right, at $700 on the graph. So 700 is in between 6 and 800 right there. That looks like it's at about 180 exactly. So that makes sense. Now, the next ones we're going to look at are when it's not quite equal, okay? Now, this is just kind of showing us, exactly what we just did, the steps. So we're going to kind of run through it pretty quickly, but it says, now maybe Alan has to make a deposit for the trip. So before he can actually be signed up for the trip, he has to pay at least $1,100. So we would say, when we see that word at least, remember we said at least meant greater than or equal to. So we set f of b greater than or equal to 1,100. We plugged in our equation. This is what we were just doing up there. Subtract both sides by 25, divide both sides, and we get 286.66. Now, this is, something that's not exactly on the graph, right? It's not, a nice even number. And you can't sell 286.66 boxes. So if we were going to explain this in words, how would we explain this in words? Would we say, greater than 286? Would we say greater than 287? Because, if he sold 286, that actually wouldn't equal 1,100. 286 would be a little bit too small. And you could even test that out, like 3.75b is, the b is going to become the 286, right, plus 25. And if you type that into a calculator, you end up with 1,097.5. So we're really close to 1,100, but we're not there. So Alan would actually have to sell at least 287 boxes. Right now, technically, the right answer is, b is greater than or equal to 286.66 repeating. But since we can't, sell that many of a box, if you were explaining it to someone, you would say 287. So we're going to kind of look at a few more like that. So I'll kind of skip through the work a little bit since we've done it a lot. What is the greatest number of boxes Alan could sell and still not have made $600? This is another kind of tricky word. Okay, what do we think? Does this mean less than, greater than, less than or equal to, or greater than or equal to? Try to think about that on your own. Okay, if he still had not made $600. So he's not there yet. Okay, he's not there yet. That's smaller than $600. So we're not there yet. We're not including it, so that's why it's not less than or equal to. And we're not there, so we're smaller than it. We haven't reached it yet. Okay. So 3.75b plus 25, less than 600. We'll subtract 600 to both sides. Sorry, we'll subtract 25 to both sides. That's my fault. We'll subtract 25 to both sides. We get 575. Should be a b there. Then we'll divide both sides by 3.75. Okay. And on this one, when we divide by 3.75, we get 153.3 repeating. So what is the biggest number he can make? Okay, this one's actually not asking for an equality. It's just asking for one number. So what's the biggest number that Alan could sell and not have made 600 yet? Well, the biggest number would be 153 boxes. That would be our biggest number that he hasn't reached it yet. So sometimes reading a question carefully is important to realize like what the answer was. Okay, next it says at least how many boxes? Remember, at least this was our greater than or equal to symbol. Would Ellen have to sell to make 1,500? So we're going to say f of b is greater than or equal to 1,500. Same process, 3.75b plus 25 greater than or equal to 1,500. Subtract 25 to both sides. That's going to leave us with 3.75b greater than or equal to 1475. Now we're going to divide both sides by the 3.75, and that'll give us b, in this case, is greater than or equal to 393.3 repeating. And again, this is a perfect answer. If you box this on a test, I'd give you full credit. But, if we wanted to say it in words, we would probably say he would have to sell at least 394 boxes, right? 393 wouldn't be enough. Even though, the nearest whole number is 393, we have to round it up because he wants to make more than that. So you kind of always round with your sign in this case. If it's a greater than sign, you round up. If it's a less than sign, you would round down. If we're thinking about things that can be only whole numbers, right? Like selling a box, you can't sell 0.3 of a box. You can only sell whole numbers. So in these, we were starting off with something in y equals ax plus b. This question is, how would your method change if the inequality was in a different form? It wouldn't. It doesn't matter what form it's in. We're still going to do the same process. All right. So now Alan's camping troop hikes down from their campsite at an elevation of 4,800 feet to the base of the mountain, which is at sea level. They hike down at a rate of 20 feet per minute. So when it says, from, they start from, that's kind of our starting point. This is our y-intercept. When we see the word rate, that's always an m. Rate always goes with m, right? Rate of change is our slope. So this formula is going to be y equals, now when we go down, that's negative. So it's y equals negative 20x. We can also see on the graph it's going down. It has a negative slope, plus 4,800. Now it says let's use h of m. So we're going to convert this, the y is going to become an h of m, and the x is going to become an m, negative 20m plus 4,800. So this is the, y equals mx plus b form, and this is in function form. Identify the independent and dependent variables. The independent is the m, which is how many minutes they've been traveling. And the h of m is going to be the feet, the height, right? Feet, you can always kind of do this. If you see something like this, feet per minute, the first one is your dependent. The second one is your independent. That always works. So if you ever see something per something, the first one is always your dependent, your y value. Your second one is always your independent, your x value. So the feet, that's the height that they're at, will be our dependent. The minute, the time, that will be our independent. So analyzing the function, what's the slope? Negative 20. What's the y-intercept? 4,800. That was obvious. What's the x-intercept? Well, it looks like it's crossing at 240 minutes. And the domain on this one's a little bit tricky. For domain, kind of what I would say is, once they reach the bottom. So starting at 0 until 240. So I would say kind of 0 is less than or equal to x, right? It could be at 0 is less than or equal to 240. That's when they finish, right? Because of the context of this question. Now, if I just if I only had an equation like y equals negative 20x plus 4,800, that's a line. The domain of this line is all real numbers. But in terms of the situation, well, the situation, they start at 0 and they reach their goal at 240. So then they finish. Okay. So this one says use the graph to determine how many minutes passed if the troop is below 3,200 feet. Below, meaning less than 3,200 feet. And it says draw an oval on the graph to represent that area. So let's go to 3,200 feet. Okay. Now, 3,200 is somewhere in between 3,500 and 3,000, probably a little bit below half, right? So half would be 3,250. So if I kind of drew a line over, right, it would be this region down there. Okay, that would be the region below. If we kind of look down here, I'm thinking, these are counting by 30s, 30, 60, 90. So I'm thinking it looks like in between 60 and 90, that's at about 75. Yeah, that's about 75, maybe 80. I'm not really sure. Honestly, I'm not really sure based on that. Could be 75, it could be 70, it could be 80, somewhere in between 60 and 90. So it's really hard for me to write that as an inequality statement until I actually use my equation. So my equation was f of, h of m, right? H of m. Now we're going to say is less than 3,200. Now the h of m equation, we're going to plug in what h of m was. It was negative 20m plus 4,800. Well, then that's less than 3,200. And so then we'll subtract 4,800 to both sides. And did I do that right? Yeah. Okay, so then we get negative 20m is less than, and then this is going to be, this is kind of tricky, right? If you're doing this in your head, and you do 3,200 minus 4,800 in your head, what you can do is you can always flip these. So negative 4,800 and then 3,200. Now, because there's a negative sign, we're subtracting, okay? But what you're going to do is you're just going to keep the sign of what was the greater number, right? The greater number is the negative 4,800. So 0 minus 0 is 0, 0 minus 0 is 0, 8 minus 2 is 6, 4 minus 1 is 1, so negative 1,600. And now we're going to divide by negative 20. Remember what we said at the very beginning of class, what we do when we divide by a negative. We flip our sign. Okay, and so that gives us, I'm going to just kind of write down here, m is greater than, that cancels, positive 80. Negative 1,600 divided by negative 20 is positive 80. So basically, when they've gone for more than 80 minutes, then they're going to be below 3,200 feet, right? Because they're going down. So does this, it says, write and solve the inequality. That's what we just did to verify, the solution from the graph. That's kind of what we were thinking, right? We were thinking some number in between 60 and 80, right? Some number in between 60 and 90, and 80 is in between them. Okay? So, looking at the graph, looking at the function, the graph, we had an idea, like a good prediction, but we weren't exact, right? But when we used prediction, when we used the function, then we were able to get it exactly. So that's kind of the main difference. But otherwise, they're pretty much the same, right? We had the same, idea, but just the graph wasn't quite as exact. Okay, so the other thing I want to point out, though, is when we had this negative slope, right, the inequality flipped, right? When we had the negative slope, the inequality flipped, and that's important. So kind of completing the table and thinking about this is how many minutes, right? This is not the slope, but this is how many minutes, like the time, right, in minutes. How many minutes would pass when our height is greater than 3,200? When our height is greater than 3,200, right, that's going to be this region up here. Well, when our height is greater than 3,200, that's going to be, remember, we just found out that this crosses exactly at 80. We figured out it crossed exactly at 80. So when we're greater than 3,200, that's before we've gone 80 minutes. So that's going to be m is less than 80. Right, now greater than or equal to, we're just going to add the equal to sign. Okay. Equals 80, that's going to be exactly at 80. Then when we're below 3,200 feet, well, that's what we just solved for. That's this number that we just solved for. That was when m was greater than 80. And so then less than or equal to, that would be greater than or equal to 80. So what do we notice about each row? What do we notice is that the sign flips in each of these rows. Now, it didn't flip before. Why does it flip now? Right? Why does it flip now? It flips because we have a negative slope. So when we have a negative slope, then we're going to have to divide or multiply by a negative number, right? And that's what makes our sign flip. So that's just something to kind of watch out for. All right, that's it for today. I know this was not quite as long as last time, but it was a little bit on the longer side. So in our skills, just kind of looking at this really quickly, these all should be pretty similar. I'll kind of run through a couple of them very, very quickly. So we have this function 800x plus 4,000, right? They gave us that function. So kind of box that. That's the function we're using. And, so it says use the graph to write an equation or equality to determine So, you can do it both ways. So at least 10,000, if I went to 10,000. If we hit a number exactly, then we don't really have to use an equation, right? This is counting by halves, like half, 1, 1.5, 2, 2.5, 3. So that'd be 7.5. So we could just say, in this case, since we're doing f of x, we could just say x is greater than or equal to 7.5 because it hit a number, it hit a point exactly. Okay? If you did need to show work, you can show your work. So, I could have done this. I don't have to do this in this case, but I could have done 800x plus 4,000 is greater than or equal to, right? That's what at least means. That's why I chose greater than or equal to, because of at least 10,000. And then subtract 4,000 to both sides, divide by 800, and you'll end up with this answer. But if it works out nicely on the graph, then you can just use the graph. And for the most part, I believe all of these numbers, 1 through 6, should work out very nicely on the graph. Okay, the next section is section B. Now we're going to switch this over to making a number line. So how many tickets must Elena sell in order to make at least 1,000 again? So at least, remember we said was greater than or equal to. So if we go to 1,000, okay, it hits a nice even number again. And that nice number is right at 50. So remember, the greater than or equal to is a closed circle. And we're going to point it to the right. Now, it says use the function to answer each question. So how many, that's perfect. But I'm going to just add, just to be extra, clear about it, that's representing x is greater than or equal to. Okay. So all of these are different. Like this is the less than sign. So instead of using the greater than or equal to, we'll use the less than. And then now the number is at 800. We'd go to 800, see where that one crosses, and go from there. So I'll do that one too for us. 800, right? That crosses right here at 30. Less than symbol, so it was open, and we're pointing to the left, right? Open because there's no equal to underneath it. So you guys will do 3, 4, 5, and 6. Very easy. We've gone over these. Less than, exactly. Now remember, exactly will just be a point. It's not going to point left or right. It's just the point. So be careful about exactly. This is an equality. It's just the point. You don't have any arrows. Okay. Then part C. In part C, now we're jumping over to the equations. So the function f of x equals 13x plus 52 is the number of points Leon will score. How many games must Leon play in order to score at least 117 points? Remember, at least was greater than or equal to, so we're going to take the f of x, set that greater than or equal to 117, take 13x plus 52, plug that in for f of x, subtract both sides by 52, right? And then we get 13x is greater than or equal to, in this case, we will get a calculator, 117 minus 52. So you do need to use a calculator for some of these questions. We get 65, and we'll divide by 13. And that's x is greater than or equal to 5. So he has to play in 5 or more games, right? 5 or more games. Fewer than, right? You should know that symbol. More than, you should know that symbol. At least again, and then fewer than, and then more than. So be careful about, which ones are which. And then the last one is section D. Okay, and section D are these negative slopes, a lot of them. So we have f of x equals negative 200x plus 4,000. And it says to, in this case, draw an oval on the graph and then write the inequality statement. So this one says a hot air balloon at 4,000 feet begins its descent. It descends at a rate of 200 feet per minute. Descending is why it's a negative slope. And it says how many minutes have passed if the balloon is below 3,000 feet. So we're going to go over to 3,000, kind of draw a little arrow over it, right? And below 3,000, that's going to be here. Now, I want you to put the point there, and we're not going to circle the point, right? Where is this point intersecting? It's intersecting at 5. So what this solution is going to be, we want to write the solution to each question. The answer is going to be when x is greater than 5. Now, why not equal to 5? Because it said below. If it had said, including, we would have circled the point and we would have had an equal sign, right? So why greater than 5? Well, because everything to the right of 5. All right, remember we said also, below is usually less than. but because of the negative slope, it flips. Now, I also want us to look at numbers 3 and 4. Okay, numbers 3 and 4 are a little bit different. Numbers 3 and 4, right, see, 2 has a negative slope, and then when we get to 5 and 6 have negative slopes. But 3 and 4, we didn't have an example, but these are also kind of flipped ones. And the reason these are flipped ones is it says Leah's walking to school at a rate of 250 feet per minute. Her school is 5,000 feet from her home. Now, normally when we see this, we would think that this might be the y-intercept. Okay? But if we look at the graph, it's not the y-intercept. The y-intercept's at 0. So what they've kind of done is they're asking a different question than the graph. Okay, they're asking kind of the opposite of the graph. And so that's where this one gets a little bit tricky and a little bit funky and weird. So they're asking the opposite of the graph. So at 0, we're 5,000 feet away. Up here, this is 5,000. This is when, now she reached her school. So, if it says, when we read this, it says how many minutes have passed if Leah still has more than 2,000 feet to walk. So we want to kind of think the opposite. If she's 5,000 feet away and she has 2,000 feet to walk, how far has she gone? She's gone 3,000, right? She's gone 3,000. Now it says more than 2,000 feet to walk, right? So we're going to go to 3,000. Right? Because that's, 5,000 minus 2,000. Like I said, 3 is kind of a weird one. Okay? So 3 is kind of a weird one. So I'm going to kind of make that little rectangle there. So it intersects right here, right? This is counting by ones, I believe. 1, 2, 3, 4, 5. So that's 10, 11, 12. Now, do we want to think below the graph or above the graph? This is a little bit weird. But if she has more than 2,000 feet, right, this is the 2,000 feet away, right? Like, 3,000 to 5,000, this is 2,000 feet away. So if she has more than 2,000 feet to walk, she actually has, she's further away from 5,000. So this is the opposite. Even though it says more than, it's below. So this answer would be x is less than 12, right? We want the solutions. So we want these numbers. So x is less than 12. That would be the solution. And that's just because, like I said, it's worded oppositely. Okay, this one is also worded oppositely. It's almost the exact same thing. Franco's riding his bike, and his school is 9,000 feet from his home. So you guys will do 4, just kind of look at 3. It shouldn't be too bad. All right. So I know this is a little bit long video, but I think the homework is really, really straightforward and easy this time. And there's only one Matthew. Okay. So if you guys need until Sunday to finish it, you can take until Sunday to finish it. I know this was a lot, and I will see everyone in class on Monday.